Hi guys, we are going to take a look at the examples from your reaction mechanisms graphs notes. So make sure you read through these pages and annotate your text. And then when you're ready, we're going to go to the second page and do the examples. So if you need to go back and do that, pause first and then come back when you're ready for the examples. So for our first example, it says use the reactions below to answer the following questions. So we've got two chemical reactions. This is a reaction mechanism, so a reaction that's happening in multiple steps. And we can see that there's a slow and a fast step labeled. So the first thing we want to do is it asks to write the overall reaction. So we've been practicing that. We want to look at our reaction and see if there's any intermediates to cross out or any catalysts to cross out. So we've got this fluorine gas that is the same on it's a product of the first reaction and a reactant of the second one. So that's going to be an intermediate. So we can cancel that out. We don't have anything that repeats as a catalyst where we start and end with it as the same chemical. So there's no catalyst. So we just want to add these together. Everything on the left will stay on the left. Everything on the right will stay on the right. And if there's more than one, we can add them together and give them a coefficient. So we have two of these NO2s plus this F2. On the right, we have two of these NO2Fs. So that takes care of all our chemicals. We can see it's still a balanced reaction. We have the same amount of each element on both sides. So it says, assuming the overall reaction is exothermic, so that's a key piece of information, we're going to sketch the energy profile. So we want to sketch a graph, something like this, labeling which peak is the slow step, which peak is the fast step, and where the intermediate is found, and what the intermediate is. So we're going to label all of those things. So first thing that we know is that it's exothermic. So we don't have values that we're assigning on here, but we do know that our products should be lower than our reactants. So I'm going to go ahead and put my reactants up here, and I'm going to put a dash down here for my products. So I've got that part established. So we know we're dropping in energy. Then I want to look at the speeds of my reactions. The slow reaction step is going to be the step that has the highest activation energy. All right, we can see in our previous graphs it's labeled EA, so energy of activation. So highest activation energy is going to be our slow step. So we want our first step to have a high activation energy. Okay, and our second step is going to be fast. So it's going to need, so our activation energy is this chunk. We're going to need it to be shorter. So I'm just going to do a little hill, and then we just need to connect it to our products. Okay, so it's a little drag on my pen. So we've got our graph drawn, which we want to label which peak is the slow step. So this is slow, and this one's fast. We can tell that based on their activation energy. So this would be EA1, and this would be EA2. Okay, so the activation energy is higher, so it's going to be greater and be the slower step. And then we want to label the intermediate. So in our reaction, we found the intermediate was the F, and that appears between the two steps, so that's going to be labeled here. Okay. So that's the first example. There is a second example. It's looking at a multi-step reaction, labeling our overall, things like that. But we've done some practice on that before. So your practice on this is looking at a couple of the graphs, analyzing them, and looking at their rate determining steps from them. All right, thanks guys.